Okay, in this video we're going to talk about angular kinetics, and to introduce angular kinetics I'm going to show a video, an exciting video of a wheel spinning, and I'm going to refer to Newton's laws of motion. But what I'm going to do is replace some of the terminology that we used for Newton's laws of motion and used angular terms. So let's look at a wheel spinning. And Newton's first law of angular motion is an object will continue to spin with its angular motion, angular velocity will be constant, unless something causes a change in that angular motion. Unless something causes a change in that angular velocity. That's Newton's first law, it's an observation. We know what a change in angular velocity is, that's angular acceleration. So when a force acts about an axis of rotation to cause a change in angular velocity, we have what's known as a torque. So torque is the tendency of a force to cause angular motion. And we're going to talk about that calculation of torque in a couple different ways. Newton's third law of angular motion is for every torque acting about an axis, there's an equal and opposite torque. And so we'll deal with this mostly when we start talking about movements in sports that involve aerial maneuvers like gymnastics or springboard diving or freestyle skiing, things like that. So let's look at these three laws of angular motion. Again, there are not really angular laws of motion. These are just an extension of Newton's laws of motion using angular parameters. So law of uniform angular motion, an object will continue with its state of angular motion, i.e. angular velocity, and the angular velocity will be constant, unless a torque acts on that object. A torque is the tendency of a force to cause rotation. Newton's second law of angular motion is the law of angular acceleration. When a torque acts on an object, it will cause angular acceleration, and we'll use this equation to link angular kinetics to angular kinematics. We will add up all the torques acting about an axis of rotation, and that will equal the product of angular acceleration and moment of inertia. We already know what angular acceleration is. That's rate of change of angular velocity. The unique thing here is we have to use units of radians per second squared. The other parameter is new, and that's moment of inertia. We know what inertia is. That's a measure of an object's resistance to change motion. Moment of inertia is an object's resistance to change angular motion. We use this equation, I equals sum of mr squared. And in words, what this equation says is, if we know how the mass is distributed about an axis of rotation, we understand that object's resistance to change angular motion. I'll go through this in more detail in a specific video. The units for moment of inertia are kilogram meters squared. And the third law of angular motion is law of angular action-reaction. For every torque acting about an axis, there's an equal and opposite torque for that torque. So these are the Newton's three laws of angular motion. An object will continue with its state of angular motion, angular velocity, unless a torque acts on the object. When a torque acts on an object, it's going to cause some angular acceleration. And then for every torque, there's an equal and opposite torque. Okay, thanks everybody.